Okay, it's time for our last talk. Jos will talk about his project, very ambitious project, which everyone, even unconsciously probably, will be aware of based on the Bevy release notes from version 0.12, I believe, where we all saw his beautiful picture on top of the release notes. So let me put Jos on stage and let him talk about his Bevy project. Jos, welcome.
Hi,
Let me
glad
show
to be here. Thanks,
yours.
Stefan, for that lovely intro. My head's still spinning from the last presentation. I'll have to
Well,
rewatch
luckily
that,
you won't talk about
Lawrence.
rendering, right?
Yeah, luckily, only mesh transformations and procedural modeling. So,
Okay,
yeah.
take it away.
Thanks, thank you. All right, hi guys. Thanks for having me, and thanks for sticking around. Today, I would like to present to you guys, my journey in recreating Townscaper using Rust and Bevy. So I wish to share with you guys what the inner workings and what the thought process looks like of a medium-sized Bevy project. And hopefully this inspires someone here to try some procedural modeling of their own. So let's dive into it. So on today's menu, I'd like to first dive into what's this Townscaper all about and why is this guy so obsessed about it. After which I'll dive into some specific challenges in this project. Sadly, we won't have time to really dive deep into some of these challenges. So do ask questions, and maybe we can dive into those a little bit later. At the end, I'll show a little online demo and stick around because there will be a link for everyone to play around with, what's out there currently. So, what's Townscaper? So once upon a time, a little younger version of myself came across this amazing little tool called Townscaper. And I think the best way to explain what this tool is just to show a small video of it. So Townscaper is a organic creative building modeling tool created by Oscar Stallberg. And it's really just a procedural modeling tour de force. It took the world by storm. And the interesting aspect of this tool is it made some really complicated ideas and algorithms actually very playful and accessible to a very large audience. This tool is very easy to use, and almost anything you make in it starts to look beautiful. As I mentioned, it's made by Oscar Stallberg, and the great thing about Stallberg is that he shares a lot of methods that he used to make this. So the blueprints are pretty much out there to recreate this. So I saw this, and I just thought that the world needs more of this. You could make city planning tools out of this. Townscaper doesn't really have gameplay, but what if you would add gameplay to all of this? And being Dutch myself, I was reminded of how the structure of those cityscapes resembled a Dutch inner city. So I was really curious to also apply Townscaper to a Dutch context. I'm still not sure which one of these three things I'm making, but let's make it. So the plan is to shamelessly create a Townscaper clone and then extrapolate from there with the whole idea of first imitating and then from there emulating and innovating, starting something new from there. What were some challenges along the way? Well, the first one is the task is huge. This is a huge project and not something you can easily just start with. So there are many components to the procedural system that makes up the Townscaper tool, which is a irregular partition, so an irregular terrain. Then a lot of tiling systems that play with that irregular terrain and make up the entire world that you see. Some really interesting asset pipelines in there as well to make sure that you can actually create those models to, be reconfigurable, then there's a very interesting algorithm in there that I won't dive into specifically today because it will take a whole another talk to really digest, called the wave function collapse algorithm, and many more. So how do we solve this? Well, divide and conquer. So the only way to tackle a problem this big is to make, to my mind at least, is to make small tiny demos and then slowly build a repertoire of procedural modeling tools from those small demos, and then afterwards try to compose them into the whole that is this whole environment. I started out with TypeScript and JavaScript and did some quick hacking around just to get a sense of some of these subcomponents. The project is still out there. You can visit this link. I'll share this link in the chat shortly if you're interested. But you'll see some really rudimentary versions of the stuff that you are about to see. These are some of the demos. So this is a marching cubes algorithm, just a way to make some terrain. This is actually wave function collapse for those who are in the know-how, and just some rendering tools, and a sort of prototype that's starting to look like the spherical project that you saw in the beginning. But that TypeScript and JavaScript environment had a bit of a, it had a ceiling. So I decided to transition to Rust to just gain a lot more performance, a lot more precision, especially for some of these procedural modeling algorithms. You really want to dive into specifics. And JavaScript was just not cutting it for me on some of those algorithms. And why not C++? Well, Rust is just a way more modern environment. And I think in this audience, I don't have to promote Rust anything more than is really needed. One thing I'll mention, though, is the mono repos and the way that examples work in Rust were really defining features that make me adapt this whole environment. Especially the mono repo really helped with that decoupling ID. It made it really easy to just, make small examples, make small little iterations, and keep everything in sync. It did, however, complicate the open source sharing of some of these components, which I'm still looking into how to solve that. Because as you might expect, in a mono repo, everything starts to interconnect, and then it becomes harder to just share one component of it. Why did I choose Bevy? Well, this might be not a very flattering comparison because Bevy is way more than just a 3.js thing, but for me, it really was just a way to hit the ground running within the Rust ecosystem. But along the way, I discovered that Bevy actually has so much more to give, especially in, for me at least, the area of adding niceties to Rust, like how it deals with global variables in the form of resources. Stuff like that are just amazing. A second challenge was to spawn that irregular grid. You see it here in the background. So what makes Townscaper so interesting is that instead of taking a voxel grid approach, decides to curve this whole environment, which gives this signature organic feel to the whole environment. But you might expect that this is quite hard to represent with normal mesh data structures. And within these procedural modeling tools, you want to store these types of systems so you can start iterating on it. Like, oh, let's subdivide one of these pentagons further, or let's subdivide this triangle into 4 quads. If you can't store it, those sorts of procedures will start to be very complicated. So what's a data structure where you can store squares, pentagons, triangles? And I decided on a polyhedron data model. It's like a mesh, but it can support up to n-gons. With this data model, I was able to support operations like subdivision and removing an edge between 2 triangles, for example, to make a quad. the implementation is based on a half-edge data structure. For those who don't know, a half-edge is a way to very efficiently store these types of systems where you can have triangles intermixed with quads, intermixed with pentagons or n-gons. And I won't dive into very specifics, but you see that it's based on a pointer system where each half edge points to the next one and to the opposite, and which in this way, there's always a way to transverse this data model, and you can start building functions that, for example, query one polygon out of this whole system, or or all the edges around the vertex. Here, I also show a bit of my approach to how I model these things, and that's keep it dumb, keep it simple, and move on. I've seen some half-edge data structures in Rust that use more involved pointer schematics, but just in practice, for me, it's turned out to always be for me at least, it was always nicer to just keep things very, very simple, very dumb. So these pointers are just use sizes at the end of the day that just point to a value in a vec. And this way I could get around the classic problem of not being able to represent a linked list in Rust. And yeah, I just also have just the advantage of just everything stays dumb. So it made it so that I could just iterate real quick at the cost of some nicer pointer arithmetic, which you could do if you actually fire some or add some like type legends to problems like this. All right, so with that data structure in place, we can do operations like this to actually spawn grids like this. I won't go over the specifics, but in here you see a procedure where it's basically a couple of subdivisions of a big hexagon, edge removals, and if you guys want to show, I can show you more specifics about this system maybe after the presentation, but let's not dive into specifics right now. The fun thing is that this also works on practically any surface. So a sphere is also not a problem. We start here with an icosahedron, and we start subdividing that a couple of times into lots of little triangles. We merge some of these triangles to quads. We start relaxing this whole system, and you're left with these lovely, groovy terrains. Then a third challenge, which is like, okay, we now have these great grids, but they're empty. Let's try to spawn some assets on it. And they're immediately met with the problem of like, okay, I have these nice assets and some tiles. I modeled some cute Dutch buildings also. But how do we translate those things? The solution is actually quite easy. It's a trilinear interpolation. So what we do is we take all the input data. We essentially build a bounding box around all that input data piece by piece, where we try to find where of that mesh, a vertex in that mesh, where is it located in a normal space. Let's do that again. When we have a bounding box surrounding an object, take a vertex, then figure out the normal location of that vertex within this bounding box. And then with that normal location, we can actually interpolate it back into some other box located somewhere else. And if you then use a octoid, so let's say a cube, but warped in some manner, where all the vertices don't necessarily nicely align, but are warped a bit, then it actually becomes possible to take just a simply normally modeled mesh and translate it to this funky grid. The problem arises when you have components that span multiple of these sort of cubes, or where the bounding box is not all that easy to define. And in that sense, or in these situations, it's yeah, the solution was to actually use several small little bounding boxes of a initial asset, and then translating it for every one of these little bounding boxes into the corresponding associated cube in the world, if that makes sense. For that we do need to specify all those bounding boxes where those can be expected, and those were just stored in the code. I don't know how we're doing on time. I think we have a small little, probably some time left for some demo. Let me quickly share with you guys the link in the chat, so you can also play along if you want. It appears I cannot talk to the chat right now. Okay, we'll have to do that afterwards. Maybe that's better as well. Let me quickly run it just locally. Sadly, due to the edge detection not yet working, the edge detection is a feature that's currently hard to do with just WebGL. So you will not see these nice edges in the browser-based version. But this is the current project. So to reiterate on what we just, what I just showed you. First of all, now that I have you guys all here, I can tell you about some cheat codes in here. If you press the grave button, you can open up all the debug information, and you can start playing around with some of the parameters that actually generates this whole Earth. So these parameters right here actually control the the subdivision system that was just that I just showed. So you can see some of the effects of these parameters and how it affects the actual generation of the terrain itself. You can also see how what happens if you now spawn one of these larger objects, spawning multiple of these tiles. Let me make a better example of. Here you can see what's happening a bit. So these are, this is sort of the bounding box of this object. And you see that it tries to warp itself into place in all these cells. And that's where we're at currently. So what's next in this whole project is to actually add wave function collapse for those in the know-how. That would make it possible to, right now you see that it's just a simple terrain model. This is marching cubes for those interested. But with wave function collapse in place, folks will not have to place individual assets everywhere. You could make way more interesting things where you can sort of paint something like city structure somewhere, and the algorithm will do the rest in actually giving that city structure shape, spawning assets. And the most amazing part of it is that based on what you draw, different structures could emerge, different assets, different tiles will start emerging based on specifically how you configure your city morphology or something like that. So looking forward to adding that. The next steps of actually turning this into a fully-fledged game. So thank you guys for your attention. I'm Jos Veenstra. You can find more on geofront.nl. Was a pleasure. Thanks.
Thank you so much, Jos. That looks so cute. And someone in the chat just figured out that it's unbelievable that there's no UTF-8 emoji for windmills. How dare they?
Yeah,
I also dug out the link from your slides and shared it in the chat so people can hopefully
Thanks.
still chime in, check it out, and leave some questions for you here. Amazing project. I'm curious to see where it goes. I mean, you kind of hinted at the end now that it will go into what's the direction of a game, even though you said it's not clear yet. But it would be a shame if not.
Yeah, it's that was the original goal of seeing Townscaper, playing with Townscaper, and then being like, oh, this could be so great if it could be the basis of something bigger. You know, if it's could, it may even be. Yeah, I believe it could be as big as Minecraft at the end of the day. It's just a voxel world, but a bit more groovy, a bit more, cute to look at, as you said.
Yeah. Okay, we have a few questions. Let me ask you one before we switch over to a panel conversation with the rest of the folks.
Please do.
Did you open source your polyhedral or polyhedron implementation or any of your work that you?
I did. But I hinted at why I'm. So there is a crate called Hedron online, in which you can find some of that polyhedron code. I will say that it's terribly outdated due to the fact that I described in the presentation, where I decided to, just for project velocity's sake, adding everything to a monorepo. But it also meant that all my code became interlinked and very hard to share only a tiny bit of it. So I'm afraid that since I took Hedron out of that open source crate and into that monorepo, I no longer have shared those updates. And I'm not sure if I want to share the entire monorepo yet, because there's just a lot in there. And also,
would it be possible to share subparts via submodules or something like that?
Definitely, and I'm looking forward to doing that once things stabilize on this end. Okay,
cool. Jos, amazing project, and definitely very ambitious, like you pointed out, to copy such an enormous project. Do you from all Oscar's knowledge sharing know how long he worked on Townscaper?
I think the whole trajectory, because he also built a great game called Bad North before Townscaper, where he explored some of the ideas, then perfected, I would say, in Townscaper. And I think that whole trajectory was around like 4 or 5 years, but don't quote me on that.
Yep.
So, yeah. We'll see how long this takes.
Some work ahead of you.
Yes, definitely. But looking forward to it.
Okay, Jos, hope you get a big hand from chat, and I'm gonna pull the rest of the panelists on, and then we can go across the entire remaining questions. There's a bunch of stuff that we still can talk about here today. Okay.
Perfect.